Welcome back, mathematicians. In this video, we are going to learn how to simplify a radical, specifically a square root. So in order to do this, it's really helpful to have a list of perfect squares. Now, this is not an exhaustive list. This is just, I think, the most commonly used perfect squares that you'll need in order to work through this process. So let's start with 2 squared, which is equal to 4, 3 squared, which is 9. You've got 4 squared, which is 16, 5 squared, which is 25, 6 squared, which is 36, 7 squared, which is 49, 8 squared, which is 64, you got 9 squared, which is 81, 10 squared, which is 100, 11 squared, which is 121, and finally 12 squared, which is 144. So again, this is not the complete list. There are more. You could continue with 13 squared, 14 squared, so on and so forth. But really, this is a pretty good list, I think, that will serve you well. So let's go ahead and look at 294. The goal here is to try to find a factor of 294 that is on this list. So let's go ahead and look at all the factors of 294. So we see that 294 is equal to 147 times 2. Unfortunately, neither of those are from this list, so we just cross those off. Then we look at 21 times 14. So again, neither one's from that list. But what you notice is that 7 is a factor of 21 and 7 is a factor of 14. So that gives you a hint that we should have a factor of 294 that is 7 times 7. Okay, so let's see that 7 times 7 is 49. So 49 times what equals 294? And the answer is 6. So what we can do is rewrite this radical as the square root of 49 times 6. We can then, property of radicals allows us to break this up into the square root of 49 times the square root of 6. Finally, we're going to take the square root of 49, which is 7, and then we drop down the square root of 6, which is as simplified as we can take this. So the square root of 294 is equal to 7 times the square root of 6, which is in its simplest form. Let's now repeat the same process for 80. And again, 80, we want to look at all the possible factors of 80, the pairs of factors of 80. So right away, I think of 8 times 10. Okay, so 8 times 10. I look at 8 and I say, oh, that's got a factor of 4. So we go ahead and look at 4 times 20. Interesting. Now, you might say that that's the choice because 4, of course, comes from the list to the right. But what we also notice is that 4 is a factor of 20. So our goal here really is to pick the largest possible value from the list on the right. And so what we can see here is 4 times 4 is 16. So is 16 a factor of 80? Well, it is. 16 times 5. So the fastest way to do this is to find the largest possible factor from the list on the right. And so we can break this up into the square root of 16 times 5, which is the square root of 16 times the square root of 5. And the square root of 16 we all know is equal to 4, so it's going to be 4 times the square root of 5. And that's its simplest form. So you might be curious about what happens if you don't recognize that 16 is a factor of 80, and instead you look at the factor from that list as 4. Well, we can still do it. It just takes a few more steps. But what we see here is that we'd have a factor, or we'd break up 80 into 4 times 20. We would then get the square root of 4 times the square root of 20, which is equal to 2 times the square root of 20. Now you might be inclined to say I'm done, but what we again think of is, well, is there a factor of 20 that is also from this list? And the answer is yes, 4. So we can break up 20, and so we say 2 times the square root of 4 times 5, which is equal to 2 times the square root of 4 times the square root of 5, which is equal to 2 times 2 times the square root of 5, and then finally we have 4 times the square root of 5. So you can still get there even if you don't pick the largest value from that list, but as you can see, it does shorten the amount of work that is required if you do pick the largest possible value. All right, guys, good luck.